This is my latest project that I've been working on for the ARRL Centennial Convention next weekend. This is a combination of a few parts that I had laying around that I had purchased for other projects, and then the projects never really got done. So I was looking for something a little fun to take with me to convention that I could wear and that would use up some of the parts that I have kicking around. This cost me $0 out of pocket for this particular project. The screen is a JY-MCU 3208, which is a Chinese board that is made for a clock application. It has an ATmega 8L on board. It has a driver circuit for this 32x8 LCD panel. It also has 3 buttons down the side that are user programmable. There's no power regulation on board, but there is a barrel jack provided. And there actually are footprints to add other things to this board, like a real-time clock and a temperature sensor and some other things. I didn't add any of those things. I just reprogrammed the ATmega 8L using the programming header, which is here on the right side of the board. It's got a 10-pin ICSP connector. Well, if I was going to wear this to convention, I needed some way to power this thing remotely. The ATmega L will work down to at least, I believe, 3 volts. So that put it in single cell LiPo territory. What I also happened to have that I had purchased for hacking purposes were a couple of these. These are made by, as you can see, Rayovac. They are emergency cell phone chargers, and they have a small LiPo battery inside. But they also have the charging circuitry and actually power regulation circuitry to get 5 volts out of a LiPo. I didn't need the 5 volt circuit, but I did want the charging circuit. So what I ended up doing is cracking this open. I had 2 of them. And extracting the board, which you can see here. The board has a bunch of things on it that I'm not using, the power regulation circuitry. But it does have a couple nice features, whereas if you push this button here, it gives you an indication of the battery level. 3 blue LEDs indicates a full battery, and those will drop as the fewer will light as the battery voltage goes down. Also, it has a charger that is powered from a micro USB port in the end here. If I plug that into a cell phone charger, it will charge the battery. And now I've taken the default battery, which I think was 850 milliamp hours, and replaced it with a 1500 milliamp hour battery out of an old PDA I used to have that is broken, has a broken screen now. And it charges it just fine, and it runs this circuit quite well. I ran power from the battery, from the charging circuit where the battery contacts connect. It's underneath this plastic here, through this wire that has become the lanyard for this thing. And this is going to be a name badge that I'm going to wear to convention. I haven't finished the software programming for it. I just now have finished the hardware side of things. I mean, it's not pretty. It's kind of like if the Borg went to Walmart kind of construction with sticky tape and whatever I happen to have laying around. I think these are pieces of a milk bottle, but they provide good insulation. I put a layer here to protect the board. You can see that this is the edge of the LiPo and the charging circuit, and then I put another piece on the back to protect the back of the LiPo and to provide a place for the wire to be routed here. And it's just held together with sticky tape. So, like I said, there's no regulation on the board, but if you do plug this in here, everything is happy on the voltage provided by the LiPo. So, plug it in, and you'll see it's running a clock program. This is actually written by another user of this particular board. I just put it on there for a demo, proof of concept. The software that I'm going to write is probably going to be a modified version of this code, using the driver from this code to put on my call sign and where I'm from, Maidenhead locator, that kind of thing. So that'll be scrolling across the screen at the Centennial Convention as it's hung around my neck. I always have problems reading people's name tags at these things, and the display here is about 6 inches long and an inch to an inch and a half high. I don't think anybody will have trouble reading it. The way this code is currently set up, the buttons allow you to set the clock by pressing and holding the button. It increments or decrements the time. The little dots along the side indicate the passage of seconds during a minute. And this button here controls the brightness. There's 4 levels programmed into this code. The driver circuitry on this board is actually capable of 16 different levels. So I'll have to experiment a little bit with that, but to see what the optimum brightness is, the lowest setting is kind of dark for inside. This one looks pretty good in person. It's a little hard to tell on the screen because of the flicker, but so over the next few days I'll be modifying this code, probably just putting in static images 32 by 8 of what I want this thing to say. And if I have the time and the inclination, maybe some sliding in and out animations to make it a little more visually appealing. But all in all, I'm pretty happy with it. I like the fact that the charger is built into the circuit here and that the thing works. And using this lanyard as the power is not anything new. I've seen convention badges that use Ethernet cords to do the same thing. But I had this power cable with the right with the right barrel connector rather on it. I figured, why not use it? So that's the display. And in Connecticut in a week, if you're at the Centennial Convention, you'll maybe see me walking around with this around my neck. Thanks.